Now let's go back to rest of the session. For the rest of the session, we will switch back to Power Query. So in order to do that, I want you to download these CSV files. So you have downloaded those CSVs and you can just right click on it and you can do extract all. So that will extract the CSVs in here. And if you look inside, there are 5 CSVs in there. So we'll be loading those 5 CSVs. And we will create relationship between these different tables because they are related to each other. All right. So let's open up a fresh new Excel. Now the same drill as yesterday. So I will go to data. I'll go to get data and I will do from CSV. And now I will go to this PC. Probably it's in downloads. So I'll go to downloads, one CSV. And we have got all these items. So let's start with cells. Okay, so I have loaded the cells CSV in here. I will go to transform. So we have got this one table in, but I want to get all those tables in at the same time so that we can see what things are in all those different tables. So once I'm in here, I will click on a new source and then I will again do file CSV. And then I will now do the transaction. I will continue doing the same thing, new source file CSV. I've got transaction. I will go to invoices. And you can do it in any order, like it doesn't matter. So I'm just trying to get all 5 of them here. I will do file, CSV, invoices, item list. Okay, go invoices, item list. And we have got file, CSV, and items. I think that's all 5. Okay. All right. So now we have got these 5 tables. Now we will do a little bit of exploration, see if there is some cleaning that we need to do, and then we will load them up. We'll probably also create relationship between them as well as we go. Right? So the first thing we will check, obviously, is what are the columns that we have. So this one has timestamp. This has got sales reference, transaction reference, terminal reference, user ID, and customer reference. Okay. So maybe this customer reference gets connected to customer table. Maybe this sales reference, this is the sales table. Transaction reference, hopefully that connects to a transaction table and we have got a transaction table in there. So that's probably where it goes. Terminal reference is probably telling us which terminal that this sale was made from. So whether it was POS, whether it was online, or whether it was self-serve, those sort of things. And user ID is who was the user who made this sale. So whether this was Ashley, Ron, or whoever that employee who made that sale. And the customer reference is the customer who bought it, right? So there were some customer references. There are null as well. And not all the customers that you sell your items are your enrolled customer or customer that have signed up with you. And this actually is data for movie ticket sales. So when you go to a movie, you can be a member with them so they will know which customer you are. But you can just rock up there and then just pay money. Signing up as a customer is not mandatory to view that movie. So there could be a lot of the sales where you just don't know who the customer is because, they haven't signed up. They just rocked up, bought a ticket and see the movie. So that's completely valid data that, you just don't know who the customer is, but you made the sales. And that's what these nulls represent is, you just don't know who that customer is. This is came and was the movie. And there is obviously the timestamp. And let's have a look at the transactions table. So transactions tables have got transaction reference. And as soon as I see that, I remember the transaction reference from the sales table. And now I think I can think of the relationship between these 2 tables. So there is a transaction reference on the sales table, transaction reference on this table as well. So this is where maybe I can create relationships. And then this table holds the detail about the transaction. So which terminal the transaction was made, what was the invoice that was involved in that transaction, what was the transaction type, whether it was cash or card, whether the transaction was successful or not, and when the transaction was made, and who was the user who made that transaction. Okay, so all these informations about the transaction is in transaction table. And now I can see this invoice reference, and I'm hoping that I will see this invoice reference as well in the invoices table so that I can get more detail about this invoice. So we'll go to invoices table and the invoice reference is there. And there is also invoice item list reference. So I'm hoping that this reference probably exists in some other table so that I can build this relationship. And now on this table, I can see a lot of information about invoice, like when the invoice was issued, what was the total amount, has there been any discount, has there been any tax, whether there has been a GST, and what the final amount was. And then it also talks about invoice status, whether it was pending or paid. It also talks about due balance and paid balance, all those kind of things you can see about the invoice. And it also shows you the points awarded for that particular transaction. And if we keep going down, there is invoice item list, where there is invoice item list a reference. There is the item ID and what the amount for that item is, right? So there is the item ID, because in one invoice, you can have multiple items, right? So what it is doing here is it is connecting every invoice with the item that was bought in that invoice, right? So if there are 5 items bought in that invoice, there will be 5 entries in here saying invoice number 1, item 1, invoice number 1, item 2, invoice number 1, item 3. So it's connecting that invoice with each item that was sold in that invoice. And then there is the item table itself, where it details about each item. So this item is the Oppenheimer movie ticket for this show date, which starts at 8 a.m., finishes at 11:20. Runtime is 200 minutes. That's the standard show type. And it's on weekend, so the price is maybe a little bit higher. And if it is a special show, maybe it's even higher. So all these kind of details about what item was sold. Okay, so that item, the same item can cost different amount of money depending on whether it's weekend or weekday, whether the show time is good or bad, whether there is like 3D or not, all those kind of things. So that's why they have got lots and lots of items. And that's why we will look up for the items and it will tell us exactly what the price for that item is and all the other things. Okay, so it's just how typically you will see data in multiple tables, because each table is responsible for storing data about one entity. So this item table doesn't care about who is the one buying it, because that's a different thing. It only stores information about the item, like what the show is, when does it start, when does it finish, how much it's cost, all those kind of things. Invoices, again, don't care about like whether who was the terminal or which terminal was processed or all those kind of thing, or who is the customer buying this. The invoices table don't care about that. And sales table, again, it doesn't care about what the item was on the sales or whatever. It cares about this was the transaction made to this customer by this salesperson. And that's what the sales table care about. And this is how data is structured in databases. In databases, you will find tables like this, like sales table, transaction table, invoices table, all those kind of different tables. And when you need to do your analysis, that's when you will start combining those tables. And that's when those patterns and analysis emerge. Right? For instance, if I were to find from using these tables, who is our most frequent customer, or who is the customer who has watched the most amount of movies with us for the last month, then I would need to join all these tables to get that information, because that information doesn't exist in one table alone. So I need to combine this sales table with the transaction table, with the invoice table, with the items table to find out what movie it was. And I will be able to work my way backwards and then say, okay, this person has watched the most amount of movies for the last month. So that's how a typical load looks like. And that's where we will try to join these tables and see how we can make it work. So first thing first, let's talk about cleaning this a little bit. And when we're talking about like cleaning the data and stuff, we need to know what the purpose of it is. So if the purpose of our analysis is affected by nulls being in there, that's only when we will maybe try to get rid of those nulls or maybe replace those nulls with something. For instance, this is quite tempting that say, okay, this thing has a lot of nulls in there, so I'm trying to get rid of those nulls. But that's not the case here. If you can get rid of those nulls, now you will be losing all the information about the people who just came in there, bought the ticket and saw the movie. So they didn't sign up with us, but they still came there. We still made the sale, but we just don't know who they are. So getting rid of null from this is not a good idea, which is like the user ID, which is, it's telling us who made this sale. So there are some user IDs and there are some nulls. And if we look at these nulls, there is some patterns in these nulls. And those patterns are, when it's an online purchase, there won't be a user ID because it's not someone that made the sale, like people just went online and bought the ticket. Right? So it doesn't attribute to a salesperson because it was just online. And same with self-serve as well. Like you just go to the movie theater, there will be those self-serve machines. You just click there and bought your ticket. Then no one is serving you. So that's when the user ID in there will also be null because it wasn't someone who made the sale. It was the customer itself. Right? So these nulls as well have got meanings and we cannot get rid of these ones because they represent something, which is, people bought this thing online or people bought it on self. When it is empty, it's either self-serve or online. But when it's a POS, then obviously someone has to be in that POS so that they can process the order. So these are the kind of contextual information you need when you are doing the data cleaning. It's not always black and white saying, okay, as soon as you see null or as soon as you see blank, you start to get rid of that. It doesn't work that way. But what we need to be really cautious about is the columns that we will use to join with other tables. Because that's when we really care about the integrity of that column. For example, this transaction reference will be used to join with the transactions table. So when we make that join, what will happen is if an ID number 1 exists on this table, and if an ID number 1 exists on this table, we will get a match. But if there are 2 ID number 1 here, then what will end up happening is the record in here will get duplicated now because there is 2 match in here. So the first will match with the first number 1, and then the second duplicate will match to the second number 1. And it will start to get worse if there are 2 duplicates in the 2 tables. So we need to make sure that we don't have duplicates, or even if we have duplicates, we know the reason, or we know the context behind, okay, how we can have a duplicate and what is the consequence of that. So that's what happens when we are talking about these joining columns, is we need to be extra careful whether this column is ready to be joined. And same with nulls as well. If this first table has nulls for some different reason, and then the second table has null for different reason on the same column, when you get joined, it will join those nulls with nulls as if they are the same thing. Because from Excel's perspective, null is a null. So the requirement before you do those joins is to make sure that you don't have nulls. And then second is make sure that if there are duplicates, you know the context behind the duplicates and it's okay to join on those duplicates. So in our case, what we need to do is the transaction reference, it cannot have nulls. So we'll just do remove empty. So it will remove all the nulls. And what I will also do is I will remove the duplicates as well, because there cannot be duplicates on transaction reference. So that way, what I did is I just removed the nulls and duplicates from these 2 columns, because these 2 columns are required in those joins. So I'll move on to the transaction table and I will do the same. So the transaction reference, again, it cannot have empty and it cannot have duplicate as well. So we remove the duplicates and we filter the rows. All right. Other than that, I think we will be okay. But now let's try to merge these tables. In Power Query, it's really easy to merge. You can see these merge queries in here. So just use this drop down and there are 2 options available. One option is you have an existing table and you merge new information from new table into this existing table. The other option is you have these 2 tables, you want to merge and you want to store the result as a separate new table. And most of the time that's a bit easier. And if you do mess something up, it's easy to just clean up that table and start fresh. So that's why I usually prefer just to merge queries as new, so that you have got these 2 different tables to begin with, but you merge them to build this new table. So that's the option I'm going to use. So I'll go to the sales table. and I'll click merge queries as new, and it will give me this interface. And this is where I need to define what is the criteria that I need to put in to merge these tables. So the first table is sales, and the column I need to select from sales is transaction reference. And the second item is transactions, and the column I need to join on is transaction reference. And I have got multiple options here. Fuzzy matching, I won't worry about that, but I worry about this, which is the join kind. It's a left join, right join, full outer, inner, left anti, right anti, whatever we want to do. And we, again, like we talk about all these different kind of join in SQL as well. So when we're doing this join, the table that you see on the upper part is the left table. And the table that you see on the lower part is the right table. And in every join, there will be a left table and a right table, and we need to understand. So left table is this, which is in our case, sales. Right table is this, which is the transaction. So now if we use left outer, it already tells it here what it does, right? So if we choose left outer, it will select all the data from the first table, which is the left table, and only the matching data from the second table, which is the right table. So when you do a left join, you get everything from the left plus the matching records from the right. And you can probably use the same concept to extrapolate what the right join will do then, right? So the right join is the other way around, where you get everything from the right table plus the matching records from the left table. And there is inner join, which is you only get the matching records from both tables. If the record doesn't match in both tables, then it won't exist here. And in our case, I think that's a better join strategy for us. Because if a transaction exists in a sales table, but it doesn't exist in a transaction reference table, that's an invalid transaction, because all transaction needs to exist in this transaction table. If there is just a weird transaction on the sales table that hasn't been logged into the transaction table, maybe that's not a valid transaction. So what I will do here is I will do this inner join. Okay, so this inner join will make sure that the record exists on both of the tables. And that's what I want for this particular scenario. So for this case, inner join makes more sense. So I will do the inner join. And I'll press OK. So as soon as you merge the query, this is how you will see it. You will see everything from the left table, and your right table will come as this table thing. So what you need to do is you need to press on this arrow, and then you will select what are the columns need from this incoming table. Right? So I will say I don't need transaction reference because I already got transaction reference from my previous table. Okay, so I need terminal reference, I need all these things. So I'll just press OK. Right? So what it did is it just got that table and it found all the columns that I selected from it. Maybe I don't want this user ID because I already have that. No, terminal reference, I think we already have it on the other table, so we don't want that either. Invoice reference, we don't have it. Transaction type, we don't have it. Transaction status and transaction timestamp, we don't have it. And I will get rid of the prefix as well. So I will just get rid of the prefix as well and press OK. So now what we just did is we just joined those two tables together and we just selectively told it what columns we are interested in. So now we have joined these two tables, and maybe we can rename this. So I will call it consolidated table. Let's try to join even more tables. But before we join the table, we need to prepare those tables so that we don't have issues while joining. The next table I think we need to join is invoices table, because we have got this invoice reference. So let's have a look at invoices table, and then invoice reference. I will immediately to get rid of empty, and then I will also remove the duplicates from here. So once I have done that, now let's have a look at this. So it has got invoice timestamp, it has got total amount, discount amount, tax amount, GST, final amount, and all these things, which I think it's okay. There probably is not much data cleaning to do. And if there is, then we can come back later as well. Okay. So now I think we're good. So let's try to merge these invoices into this consolidated table as well. So I'll go to the consolidated table, and this time I won't use merge queries as new because I want to join it in the same table. I don't want to keep creating new table again and again. So I'll just use merge queries for now. And then this is the table that we have, which is the consolidated table. And now we need to use invoice reference to connect with invoices. And that's the invoice reference that we will connect on. I think I will use inner join so that I'm sure that the transaction and the invoice that is attached to the transaction, I can find that invoice on the invoices table as well, right? So I'll do the inner join as well for this case, and I'll press OK. And again, I will do this expansion. I will select what are the columns that I want. Invoice reference, I don't need it because it's already exists in the table. Invoice item list reference, I want that. And I won't use original column name as prefix, so that hopefully you won't add that prefix in. I think it didn't add the prefix, which is good. Right, so we got all these new columns in. So we've been making this table bigger and bigger because we are joining these tables and we're importing all those new columns. So now let's have a look at invoices item list. So invoices item list has got item ID, and invoices item list is, you can see, it can have duplicates. And the reason for that is because one invoice can have multiple items. And this is the table where it combines the invoice with each of that item. So here we will have duplicates. And probably that's fine because we can still continue to join and it will be fine, right? It can be connected to same item ID twice because if they bought the ticket for the same cinema, but they bought two of the tickets, then that will be duplicates as well, right? Any duplicates here is actually a valid thing and it's there for a valid reason. So we cannot just go in here and remove duplicates. It will mess up our entire analysis because we will lose all of the information. So this is where we want to remove duplicates because duplicates in here make sense. That's because people have bought the same item or multiple items in the same invoice. So now we won't do anything in here. We will simply merge this to our consolidated table. So I will merge the queries and I will select the invoice item reference and I will go to invoice item list and invoice item list reference. And here as well, I can do inner, but for now, let's just use left. And I think both of that will give us same result. And I will press OK. So it will give me the same thing. And here I will include the item ID. I won't include amount in here because for the amount, I want to get it from the item table, right? So I'll just use the item ID here. And I won't use the prefix. So I get the item ID here. And now once I have this item ID, I can go to my items. And in here, the item ID is supposed to be unique. So there can't be duplicates in this item ID. So what I can do is I can definitely get rid of empty, and I can definitely get rid of duplicates here. Because this item is supposed to be unique. Right? So one item ID refers to this movie at this time on this weekend. So it cannot be duplicate, right? So it always has to be unique on that. So now I'll go to consolidated. I will merge it one more time. And I will do with item ID. I combine it to with items. And now again, I can leave it as left, which is fine. And let's do OK. All right. So it got me the same thing. Item ID, item 1, I need item name, blah, blah, blah. I need all of that. And I'll press OK. Yep. So now we have successfully joined all these 5 tables and look at how massive we have got, right? So we got columns from all these tables and this is the final result. So now that we have completed all the transformations. So we did some data cleaning. We did all these joins as well. So now we can do close and load, and it will do all that transformation, and it will give us the final data in here. Right? So this is the consolidated table, and has got all these other tables as well, like sales, transaction, invoices, item list. And so those are the initial tables, but this is how our final table looks like. So we have got all this massive table, and now we will do further analysis on this table. Okay, so let's start to do some visualizations with this. And every time we talk about doing the analysis, we need to think of what is the question that we're trying to solve. And only then start to look for, okay, what's the analysis that we need to do here? So for like with this data that we have in hand, let's try to answer some of the questions. And maybe one of the questions is, do we have more sales on the weekend or the weekday? Because that could be a genuine question. Like, yeah, do we have more people on the weekend or the weekday, right? So let's try to find that. So I will just select all of these. And in order to answer that question, I will need a pivot table, because that will help me summarize these things in a way that I want it to, right? And I will also add this to data model, because that will be helpful later on. And now I will start to build pivot table. So there is a column called daytime, which gives me whether it's weekend or weekday. And if I put it against the price, and if I sum that price, that will give me an indication of how much money we make on weekend and how much money we make on weekday. Because we have got 5 weekdays and we have got just how many weekend? Just 2 weekend, right? 2 days in the weekend. So what we need to do is we need to normalize this and say, okay, if this is that, then per day, how much we are making per day? We need to divide that by 5, because we have 5 days in the weekday. And we have to divide this by 2, because we have got 2 weekends, right? So we need to normalize it and say that, okay, this is not the accurate representation, because we've got 5 working days in the weekdays and 2 days in the weekend. If we were to divide that with the number of days we have in each of that, then this is how the per day sale would look like for weekdays and weekend. And looking at this, what do you think? Does this say that we make more money? Like, it says we make more money on weekend and weekdays, but do you think we're missing something? Yeah. So on weekend, our ticket prices are higher, and maybe that's why we're making more money. So it's probably not because of more people coming in. It's probably because our ticket price is more on that day. How do we take care of that? And how do we account that as well? Any suggestions? Yeah, it could be average pricing. Or instead of looking at the total price, if we count the number of tickets we sold, then that probably would be a better indication, right? Because the number of tickets sold is a better representation of whether there were more people in there or not, right? Because pricing, the total price will change depend on whether it was weekend or weekday, and that will affect the total money that we make on that day. So instead of doing the sum of price, if I can probably just put in anything, like maybe let's put in invoice item list reference, and I will remove. The aggregation I want is count. I want to count it. Right? So instead of doing the total sum of sales, I will do the count. And now again, I need to divide that by 5, and I need to divide that by 2. And that will be the proper representation. It's not dollar anymore. It's just a number. Okay, so now it is saying that on average, we sell about 1,900 tickets in a day on weekday, and we sold about almost 2,500 tickets on weekend. So definitely we do more businesses on weekend. look for those contexts as well. Okay, we can do this kind of analysis, but do we really know what's happening? But does that number is accurate representation? Do we need to do further normalization because there could be these kind of biases? So that's also something that you would always need to look out for whenever you reach a conclusion. You need to think of what are the things that might affect this. And with this pivot table, you can do all different sorts of analysis. So I want to know which customer has bought the most amount of tickets from us. So it looks like, there's blank. So there are customers that we don't know, or customers who haven't signed up with us. So they have bought 2,800 tickets. Look like I can, but I can probably just have a look at here and say that there are people who bought 27 tickets. Yeah, there is 27. And maybe that's probably the biggest one. 31 is as well. So we can use this information. We can probably extract it somewhere and then sort it by the value so that we can easily find the customer who has bought the most amount of tickets from us, or who is the most frequent customer, all those kind of things. We know we can sort this. So if you have this data, then obviously you can figure it out and sort it in whatever way you want. So that's how things would work. So let's try to do some visualizations as well. So the thing I'm interested in is I want to look at the date, and I want to look at the item list reference, and I will do the count of that. So that's how many tickets we are selling every day. And I can probably use a chart to represent that. So I will select that, I'll insert a recommended chart, and I want a line chart. There we go. So that shows the trend of number of tickets we are selling every day. So maybe we have a bit more spikes on weekends. I think if we change this chart type to, so if we just make it bar chart, does it allow us to add a legend? It does. Yeah. So that way we can look at the trend and see that, okay, this is how many tickets we're selling. And then if we want to do any other kind of analysis, we can easily do that as well. So this is how you will load the data, build those relationships, and eventually land that data into Excel. And after that, you can use all these kind of pivot tables, pivot charts to do your analysis. We can put in a filter, say, and we talked about it yesterday, is okay, I can do slicer, right? So we'll add a slicer, and then that slicer will be my, I don't know, where is that? Date type. So date type will be my slicer. So if I just want to have a look at weekends, I can just have a look at weekends. So this is how much we're doing on average daily on weekend, and this is how much we're doing average on weekdays. Right, so we can do that. If we want to get into more granularity, like Saturday, Sunday, and want to get that day out, you can also do that. So you can go to your table, and then you can say, okay, now I want to get the day out of this date column. So you can use the Excel formula to get the name of the date, and then you can do that analysis and saying, what is our most busiest day? Whether it is Sunday or whether it is some other day. So you can do that. You can look at the trend of the start time and end time as well, right? Which is our most popular time? What's the time where people come to view the movies the most? We can also find what's the most popular movie and what's the least popular movie, which movie people really didn't watch, and all those kind of analysis is now possible because we have done all this. We have joined all this table in here. And for the exercise, I have put in some questions for you guys. What can do, because this is supposed to be the take-home assignment as well. For the take-home assignment, here are some few questions that you need to answer with this data. For a given sales ID, find the number of movies bought. How many number of movies were bought for certain sales ID? So you can use that. I have give you a hint to use VLOOKUP, but probably VLOOKUP won't be sufficient for this one. So we would need to create this entire relationship, and after that, it will be just so easy. And after that, for a given customer ID, find the number of movies watched by the customer first, and also display the name of the movie. So if you can try to answer these two, or you can come up with your own as well. Okay, I want to find for each movie, I want to find the customer who has bought the most amount of ticket for that movie. You can come up with your own questions as well. So that's on the ETL process and some analysis.